Hi, physical science class. I miss you all, and I'm really happy to make this video to be able to say hi to you guys. Don't forget, you can always stop by office hours. And before we begin, I just want to introduce you to Mrs. Wu. Mrs. Wu, say hello.
Hello.
I also want to introduce you to Arnold. Arnold, come here. Arnold, come here. We just got Arnold a few days ago, and Arnold is a good dog. Aren't you a good dog, Arnold? Aren't you a good dog? Aren't you? Yes, you are. Good job, Arnold. Okay, you may resume just chilling. Thank you very much. Okay, so what I'm going to do today is I'm going to go over the most missed questions from all the quizzes you took over the last few weeks as part of our review. Don't forget, you should also go back to those lessons to review things and make sure you really know them, and make sure you take the practice quiz, and make sure you really know everything before you take the exam, because you only get one chance and it is timed, although you can use your notes, but you cannot collaborate with any partners. So let's take a look at our first question. How many electrons are in manganese? I feel like people struggled on this one because they didn't know where manganese was, or they confused it with magnesium. Manganese is right here. That's different than magnesium. Manganese has 25 protons and 25 electrons. So the correct answer was 25. A lot of people put 12, and they probably confused it with magnesium. This next question, what element is this? A lot of people put lithium, but if we take a look here, this has 1, 2, 3, 4, 5, 6 electrons, and that means if it's neutral, it has 6 protons. That's going to be carbon. Lithium, on the other hand, only has 3 protons and 3 electrons, so lithium would look something like this. So that's not what we see here, and so the answer is carbon. All right, there was a couple of questions that people missed that had to do with the flame test lab that we did, and there will be a few questions on this. First, in our flame test lab, we took different compounds and we heated them. When we heated them, electrons that were in lower energy levels got excited. They absorbed energy from the heat, got excited, and jumped to higher energy levels. Then, when the electrons relaxed, they would go down to lower energy levels and release light. So, the electrons that are on the lower levels can go up to higher energy levels. And they do this when they absorb energy. Then, when the electrons relax, they lose energy. And they lose that energy in the form of light. How much energy they lose depends on the number of levels that they're jumping down or relaxing. And that depends on different elements. And so, if I were to draw here, again, the amount of energy that they lose has to do with the difference in energy between these two levels. And that difference is different for different elements, which is why we saw the different colors. When light was given off, they released light waves, which are composed of photons. And well, when it comes to a wave, frequency is how fast or how many times a wave is repeating itself. Wavelength has to do with the distance for each wave to go up and down. Now, let's take a look at this question here. It says light is emitted by transitioning an electron from the third to the second excited state, they mean energy level, of a hydrogen atom. if the transition were from n equals 3 to n equals 1 instead, the light emitted would have. So instead of going from 3 to 2, they're saying we're going from 3 to 1, which is a bigger jump. That would be higher in energy. And if light is higher in energy, it has higher frequency and shorter wavelength, which would be this guy, higher energy. And none of the other options are correct. This is a similar question: which wave has the largest frequency? Remember, frequency is how fast, how many times it's going per second. And so basically it would be this wave right here, because it's repeating many times each second. And that's different than wavelength. The one with the largest wavelength would be this guy right here. Is this the correct way to draw the Lewis dot structure of carbon? You learn these purely during the online learning. I don't think I taught you this in person. When we draw these Lewis dot structures, we are drawing the number of valence electrons. And what you learned is that the electrons, you should place one on each side before you start doubling up. Carbon has 4 valence electrons. How do we know that? Well, it's in group 14, or what you might sometimes see as 4A. And you can even see that carbon has 1, 2, 3, 4 valence electrons on its outer shell. So when we draw the Lewis dot structure, we would draw C with 4 electrons, and we would want to put them on each side before doubling up. They doubled up here, so that's why they are in the wrong places. Why do we do that? Well, electrons are negatively charged, and they tend to repel each other. They don't like each other. So they want to be as far away from each other as possible. That's why we draw Lewis dot structures in this way. Let's take a look here. How many valence electrons does this Bohr model have? Remember, valence electrons are on the outer shell. That's 1, 2, 3. And then we see 3 here. A lot of people put 13. They counted all the electrons. That's not correct. Some people put 8. Maybe they were looking at level 2 or thinking that 8 is a common number for valence electrons. But this guy has 3 electrons in its outer shell. All right, this one a lot of people struggled on. Use the periodic table. Find the element that has 3 valence electrons and 2 energy levels. Well, let's take a look. Here's the periodic table. 3 valence electrons means it's going to be in this group right here, because this column they tend to have 1, this column they tend to have 2, and this column they tend to have 3. And that is group 13 or 3A. And so it wants us to find an element that has 3 valence electrons and 2 energy levels. Well, energy levels correspond to the number of rows. So boron would have 2 energy levels and 3 valence electrons. If I were to draw out the Bohr model for boron, take a look. It would have 2 on the first level and then 3 on the second level. And that's 5 in total, because boron has 5 protons, 5 electrons. So it's 2 on the first level, 3 on the second level, and it has 3 valence electrons. If I were to draw the Lewis structure, it would be a B with 3 dots to show that it has 3 electrons. People who put lithium thought 3 valence electrons refer to total electrons, and that's not correct. Valence electrons are only on the outer shell. Now, this question says, if an atom has 5 valence electrons, what charge will it have as an ion? Well, if something has 5 electrons on its outer shell, let's say, for example, nitrogen, which has 2 on the first level and then 5 on the second level, it wants to gain 3 more to form a total of 8. That's why its charge will be -3. A lot of people got this incorrect, so maybe this wasn't in the videos that you saw. All of these elements want to form full outer shells. That's usually 8 valence electrons. Sometimes it's 2 if we're just talking about the first level. Point is, we always want to have a full outer shell, which is usually 8. If it has 5 valence electrons, it'll want to gain 3 to form 8 and to form a charge of -3. Remember, when things gain electrons, they become more negative. This question says if titanium has 19 electrons, what charge will it have? Well, if we find titanium on the periodic table, it's right here. We see that it's atomic number 22. So it has 22 protons and 22 electrons when it's neutral. But if it had 19, did it gain or did it lose electrons? If we went from 22 to 19, it lost electrons. And if it lost electrons, did it become positive or negative? It became positive because losing electrons, I become less negative, more positive because I have now more protons than electrons. If an atom has 3 valence electrons, what charge will it have? Well, let's take a look at an example. Let's say I had 2 on the first level and then 3 on the second level. This would be the case for boron. Now, this boron doesn't want to gain 5 electrons to form a -5 to have 8 on its full outer shell. That would be this one right here. And I'm glad most people didn't select that. It's not -3 because if it gained 3 electrons, it would just have 6 on its outer shell. And that's not the magic number 8. That wouldn't be a full outer shell. What boron wants to do here is lose these 3 electrons because then it would just have 2 in its outer shell. That's a full shell on the first level, and its charge would be +3. Another way you can see that is that if we look on the periodic table, it's in group 13 or 3A, and these tend to form a +3. Remember, we have a +1, +2, +3. This forms a -2, -1, and 0 here. That's going to take us towards the very end. Let me see here. Okay, we got 3 more. But before I do those, let me just briefly review some groups. There weren't any quizzes on periodic groups. You should go back and review that information. But this group right here, alkali metals, they tend to form a +1 and they have 1 valence electron. Alkaline earth metals, which is this group, has 2 valence electrons, forms a +2. And these guys right here, group 17 or 7A, they're called the halogens. They have 7 valence electrons, and they tend to gain 1 electron to form a -1. These guys are the noble gases. They have 8 valence electrons, full outer shell. They don't tend to form a charge. It's a charge of 0. Everything to the left side of this staircase are metals, and everything to the right side are non-metals. These guys right here in the middle are transition metals. Again, you can pause and rewind and really study those and remember those. All right, which element has the same number of energy levels as nitrogen? This is one that many people struggled on. Nitrogen's right here. And when it's asking which element has the same number of energy levels, they're asking which element has 2 energy levels just like nitrogen. Or which one is in the same row as nitrogen, because everything in this row has 2 energy levels, the same as nitrogen. And boron is the only one in that list to have this to have the same number of energy levels as nitrogen because it's on the same row. What is the mass number of this atom? Well, mass number is just another term for atomic mass. It's a little bit different in that atomic mass is usually an average number because of isotopes that exist that you find on the periodic table. So this number is usually a decimal and you find on the periodic table, but mass number is a whole number of protons plus neutrons, in this case 4 plus 3. And 4 plus 3 is equal to 7. So lithium has a mass, or this atom that we see here specifically has a mass number of 7. What ion do you expect bromine to form? Well, it's in group 7 as it says, and group 7 is in this column right here. They all have, bromine, like all of these elements, has 7 valence electrons. It wants to gain 1 to form a full outer shell, and when it gains that 1 electron, it'll have 8, and because electrons are negative, its charge will be -1. That's it for the review. Don't forget about office hours, or please email me or Mrs. Wetzel if you have any other questions. Have a great week, guys.